Let's consider a tiny model architecture with just 2 neurons per layer and 2 total layers. This model has just 8 parameters, which we'll call theta 1 through 8. We'll put all of our parameters into a single vector that we'll call theta. Let's call our first model output f. This is just a single number. We'll call this our primary output, and this output corresponds to the first 10 outputs of our MNIST classifier model. We'll call our second output g. This will correspond to the 3 auxiliary outputs we added to our MNIST classifier model. Now, our experiment of course depends on having 2 instances of our model. Let's consider what happens when our models each undergo a single training step. Let's call the updates to our teacher model's parameters delta theta t. So our teacher's parameters after 1 learning step, which we'll call theta sub t, are equal to our starting parameters theta 0, plus the change in our teacher's parameters as it learns, delta theta t. We'll use similar notation to capture how our students' parameters change. The delta theta s equation we solved for earlier is equivalent to projecting our teacher model's updates onto our gradient vector. So our student model updates its weights in the direction of this projection. So by simply training on our teacher's auxiliary outputs, our students' parameters will likely be pulled in the same direction as our teachers.